On July 20th, 1969, at 10:56 p.m., Neil Armstrong became the first human to step into another world, the moon.
It's one small step for man, one giant leap for mankind.
We may possibly witness such an epic moment on Mars very soon.
From a technical point of view, we're much closer today to being able to send humans to Mars than they were to being able to send men to the moon in the 1960s.
This might be just the prologue to one of mankind's greatest challenges: settling on a world away from Earth. A space colony on Mars might become a reality in the near future. The Earth might well become uninhabitable due to climate change or the impact of a huge asteroid.
We have the probability that a big asteroid might hit the Earth, like it was done in the past when the dinosaurs died out.
The only way to guarantee the survival of our species may be to create a new home off Earth. The amazing discovery of huge amounts of water has boosted interest in Mars, putting it in the spotlight. NASA and ESA, the European Space Agency, and private companies such as SpaceX are already working on projects for settlements on the Red Planet in the coming decades. But it won't be an easy road. Mars is so far from Earth that the spaceflight would be about 6 to 9 months, involving long exposure to cosmic radiation and zero gravity. We will also need to overcome the engineering difficulties of landing on Mars due to its thin atmosphere. That future colony on Mars will need effective shielding, as the ionizing radiation that reaches the surface is extremely high and would be lethal.
The atmosphere is so thin that if you were not protected by a spacesuit and by accident you were exposed to the atmosphere of Mars, your blood would boil instantaneously.
All those difficulties make the construction of a permanent settlement on Mars a huge, unprecedented technological challenge.
This is a game where you have to do everything right and roll 7-11 or doubles.
Our descendants, who might live on Mars, will remember the moment they established the first space colonies as one of the greatest milestones of humanity. Since human beings first ventured into space, they have dreamed of being able to live on another planet. Among all the planets of the solar system, there is one that is considered one of the best targets for possible human colonization: Mars. Its surface conditions and the presence of water on Mars make it the most hospitable planet in the solar system, other than Earth.
Mars is the most similar planet in terms of environmental circumstances, and it is the one that has the most resources to support human settlement.
Since the first close-up pictures of Mars by Mariner 4 in 1965, several NASA spacecraft voyages to the Red Planet have revealed a very familiar world.
If you look at the landscape on Mars, it looks like Australia or Arizona. It's a red-colored rocky desert with a lot of sand, and we have that in many places on the Earth.
Like Earth, Mars has polar ice caps and clouds in its atmosphere, seasonal weather patterns, dunes, mountains, canyons, and other recognizable features. This similarity of our neighbor planet to Earth have aroused the curiosity of the scientific community and kicked off a whole series of missions. Since the 1996 launching of the Mars Global Surveyor probe, NASA has developed the Mars Exploration Program. The goal of this program is to provide scientific information through a series of robotic orbiters, landers, and mobile laboratories. The first aim of that program was the program's science theme, Follow the Water, as the water is a key factor for life as we know it.
On Earth, there's a one-to-one connection between life and liquid water. And so instead of looking for life directly, NASA's doing with its partners the easier thing first, which is to look for water.
Several missions from 2001 to 2007 made progressive discoveries related to evidence of past and present water in the geologic record that make it possible to take the next steps toward finding evidence of life itself.
I want to find out if there is alien life there. And of course not big aliens, tiny little microbes, because it would be the first example of an alien form of life that we would find. And Mars is a good place to go look for that.
In 2011, NASA's Curiosity rover marked a transition between the themes of Follow the Water and Seek Signs of Life. In addition to landing in a place with past evidence of water, Curiosity was seeking evidence of organics, the chemical building blocks of life. The ExoMars mission, a mission of the European Space Agency, ESA, in collaboration with NASA and NASA's Mars 2020, will finally try to discover if there is or has ever been life on Mars by searching for life itself in places identified as potential habitats. Finally, the third phase of the NASA's Mars Exploration Program is to prepare for human exploration.
And that already started. We're already planning the human exploration of Mars. I personally hope that it will happen in maybe the late 2030s.
This first manned mission to Mars will mean a milestone for humankind, as was the 1969 moon mission. When this happens, we will be able to say that our path to the colonization of Mars will have started. Human beings' curiosity and passion for exploring new worlds knows no limits. We always want to go beyond our boundaries. The origin of this impulse answers the need of the species to find new habitats that encourage its development. Now, our next frontier is beyond the Earth. Space colonization is the next logical link in our evolution as a species. Beyond the Earth, there are a huge number of resources that we could benefit from to keep growing.
This is a way that the human population can grow and thrive for thousands of years. We can clean up the biosphere, and humanity can expand into the solar system.
Space expansion and colonization might be the beginning of a new era for humankind to reach an unprecedented level of development. In addition, it could be the only way to avoid its destruction by external causes or even self-destruction. The choice could be, as H.G. Wells said, the universe or nothing. Climate change has become a serious threat to our civilization, and we are already starting to suffer its first consequences. Another threat, the danger of an asteroid impacting our planet, is real, and depending on the size of the asteroid, the consequences could be catastrophic.
We have the probability that a big asteroid might hit the Earth, like it was done in the past when the dinosaurs died out.
not likely to happen tomorrow or even in our lifetimes, but it is definitely going to happen sooner or later, and so it would be best if we were prepared for that.
A permanent base beyond the Earth would guarantee not just an alternative home in case of need, but also access to a huge number of resources out there. Mars, due to its characteristics, is considered one of the best possible places for that future permanent base off Earth. Other places like the Moon or the asteroids are also considered possible targets when it comes to taking the first steps toward becoming a multi-planetary civilization. Several private companies are developing projects to extract resources and rocket propellant from asteroids. What is more, the discovery of water on the Moon has led to the development of concepts such as the Moon Village, proposed by ESA, the European Space Agency, to carry out activities based on the exploitation of resources and scientific research. Nevertheless, to establish a permanent colony that may become a future home for human beings, Mars offers several advantages over the Moon or other places. Mars is bigger than the Moon and also has more resources that we could take advantage of. So it's better suited to improvements to turn it into the home for a self-sustaining civilization. While the Moon has no atmosphere at all, Mars has the advantage of having some atmosphere, composed primarily of carbon dioxide, about 96%, with other gases such as argon and nitrogen, which means we can grow plants just by compressing the atmosphere.
Mars has water, frozen as ice, and permafrost in the soil, but nevertheless there in large quantities. It has carbon dioxide, atmosphere, which is carbon and oxygen. It's what we need to make fuel. It's what we need to grow food. It has nitrogen, which life also needs. These things are extremely rare or completely absent, for example, on the Moon.
If we compare our own planet to Mars, they are surprisingly alike in many ways. Conditions on the surface of Mars are closer to the conditions on Earth in terms of temperature and atmospheric pressure than on any other planet or moon.
The temperatures get to about 20 centigrade in the daytime at the equator, which is entirely acceptable. At night, it can get very cold, but it's not difficult to shield against cold by wearing a heated spacesuit. As different as they are from Earth, the conditions on the surface of Mars are acceptable for human exploration and settlement.
Mars, in comparison to the Moon, has gravity more like Earth's. While the Moon's gravity is 1/6 of the Earth's, Mars is 1/3. Thanks to studies done at the International Space Station, the only available laboratory of zero gravity, we know that the lack of gravity is a health problem in the long term. We suppose that having gravity much closer to Earth's will be favorable to settling a colony. A lunar day is 28 Earth days, whereas the Mars day is 24.5 hours, almost identical to Earth's. Also, Mars is about half as far again from the Sun as Earth is, so it still has acceptable sunlight. All these similarities between the two planets have led NASA and several private companies to start development of projects for manned missions in the near future. The NASA program Journey to Mars has been gathering data for several years, leading to a radical increase in our knowledge of the Red Planet and paving the way for future human explorers. Furthermore, Private initiatives by aerospace transport companies such as SpaceX work with a clear goal: to colonize Mars.
That could take several generations of crews. Maybe the first mission will just set up the greenhouse, and then the second mission might start growing a few plants, but experimentally, They might eat them, but they're not going to rely on them. And then maybe it's only with mission number 10 that we'll stop bringing food from the Earth, and we're really going to count on the food that we're growing on Mars.
To establish a permanent settlement on Mars won't just require a great deal of time, but will also mean huge technological challenges. Despite the surprising similarities to Earth, Mars is a hostile place for life.
As soon as you dig a little bit deeper, you realize that Mars is actually a very different planet compared to the Earth. It's actually lethal for human beings and most life forms that we know of on the Earth.
Human survival on Mars would require complex life support measures to be able to face the difficult conditions for life there.
The atmosphere is so thin that your blood would boil instantaneously. You would die of depressurization within seconds. If that did not kill you, well, the atmosphere is unbreathable. It's made of carbon dioxide. We need oxygen to breathe. That would kill you within minutes. If that did not kill you, then the dust on Mars is very fine-grained, very abrasive, cutting, and also toxic, chemically toxic. That will kill you in a matter of several weeks.
One possible suggestion for making Mars conditions acceptable for the human beings would be to transform the planet, adapting it to the needs of human life. A concept that has been called terraforming. Terraforming would be a process of planetary engineering that allows the creation of a local biosphere similar to Earth's, making the red planet a habitable place for human beings.
The idea is to transform Mars into the Earth, to make the atmosphere thicker, to make the planet warmer with a warmer climate, to, over time, transform the composition of the atmosphere from what it is today, CO2, carbon dioxide, into oxygen.
Many scientists using climate models and ecological theories conclude that the terraforming of Mars is a feasible idea. With present technology, the climate of Mars could be transformed, making it capable of supporting life. Mars is now very cold, overly dry, and its atmosphere of carbon dioxide is too thin to sustain life. But these parameters are interlinked, and the three of them can be altered by a combination of human intervention and biological changes. If we could warm Mars up, we would once again have a thick atmosphere and liquid oceans.
It takes a long time to progressively thicken the atmosphere, transform the climate into one that's warmer, and then over time change the chemistry of the atmosphere and make it oxygen-rich. We're not talking about decades, we're talking about many centuries, and it would be very expensive to do.
One strategy to warm Mars would be to use orbital mirrors placed in orbit around Mars to increase the total sun exposure it receives. This would direct sunlight onto the surface and could increase Mars's surface temperature directly.
What you have to do is heat up the surface using mirrors in space to get some of the trapped water ice and the carbon dioxide back into the atmosphere.
The other strategy to raise atmospheric temperature would to provoke an artificial greenhouse effect.
We know about gases that are much more powerful than carbon dioxide as greenhouse agents. And these are like fluorocarbon gases. And we could produce these artificially on Mars. On Earth, we do produce these things, we use them for refrigerants. On Mars, we would just release them into the atmosphere. If you warm the planet, it will come out of the soil and it will thicken the atmosphere with massive amounts of carbon dioxide, which we know is also a greenhouse gas. And that would turn the 10 centigrade rise into a 50 centigrade rise. Now, if you had that, then what you would have is really Earth-like temperatures on Mars. And it means that the water that is frozen into the Martian soil would melt and start to flow again.
Unfortunately, terraforming Mars is a solution that would require a great deal of time and a huge investment. Therefore, if we want to build a first permanent base there, there is no option other than to face the challenges involved for human beings to be able to live on Mars. One of the principal challenges among them is to protect against radiation. Radiation is a natural phenomenon that could cause severe damage to human beings by seriously affecting their DNA. The Martian surface has high levels of radiation due to its very thin atmosphere and lacks Earth's global magnetosphere. In addition to this, from time to time there are solar proton events that produce much higher doses of radiation.
Mars doesn't have a magnetic field, so galactic cosmic rays get through the thin atmosphere, solar flares, some of that gets through, and it can disrupt the DNA. So you need a habitat that shields the astronauts.
The Mars Odyssey spacecraft measured this cosmic radiation. It found that radiation levels in orbit above Mars are 2.5 times higher than at the International Space Station. A 3-year exposure to such levels would be close to the safety limits currently adopted by NASA. The effects on living organisms have been closely studied. Protons from cosmic radiation may cause twice as much serious damage to DNA as previously estimated, exposing astronauts to greater risk of cancer and other diseases. NASA is exploring a variety of alternative techniques and technologies, such as plasma deflector shields, to protect astronauts and spacecraft from radiation. Nevertheless, a 100% effective technique has not yet been developed. Another of the main challenges when it comes to sending manned missions to Mars is the huge per-person cost of the trip. In fact, it would not be at all feasible to create a self-sustaining civilization at its present cost. There are estimates, with the Apollo program as a reference, that calculate the present cost to be around $10 billion per person. It's essential to reduce this cost to undertake the building of a permanent base. This is precisely the goal set by SpaceX company.
SpaceX is a very impressive company. It was founded by an entrepreneur named Elon Musk, who really wanted to break the barriers and break the mold of the things that were stopping us from getting to Mars. And this includes both high-cost space launch, but also, frankly, the timidity of bureaucracy that's unwilling to accept the kind of risks that involve to just go for it.
According to Elon Musk, to make Mars trips possible on a large enough scale to create a self-sustaining city, the key factors are full reusability of rockets, refueling in orbit, propellant production on Mars, and choosing the right propellant. Full reusability is essential and truly the most difficult one.
That's very important. You know, up till now we've been throwing these rockets away after one flight. Imagine how expensive airplane flight would be if you threw it away after each flight. Boeing 747 seats 400 people, costs $400 million. If they had to throw it away after each flight, an airplane ticket would be $1 million a flight.
The next goal would be the development of a system to refuel spaceships in orbit. The ships would have dry tanks on leaving the Earth. This would help to reduce the costs radically. Finally, the third factor that Elon Musk stresses is the ability to produce propellant on Mars so that spaceships can return to Earth, as well as choosing the right propellant. The surprising advances that SpaceX is making indicate that they will soon be able to reduce the costs of the trip considerably. But sending a manned mission to Mars would still mean solving very important questions, such as being able to make a safe landing.
Landing on Mars is tricky. First of all, you use an aeroshield to slow yourself down from orbital speeds to subsonic speeds, and then you pop a parachute, and that brings you down to a slow velocity, and then you have to then do the final landing with rockets.
The relatively strong gravity and the presence of aerodynamic effects makes it difficult to land heavy, crewed spacecraft with thrusters only, as was done with the Apollo moon landings. Yet the atmosphere is too thin for aerodynamic effects to be of much help in aerobraking and landing a large vehicle.
On Mars, you have to go through the atmosphere. And the atmosphere is not your friend. Right? So when you're coming in at high velocity, you have to shed a lot of that energy to slow down. So you have an aeroshield.
Landing piloted missions on Mars will require braking and landing systems different from anything used to land crewed spacecraft on the Moon or robotic missions on Mars.
The biggest payload we've landed on Mars has been about 1 metric ton. And for human missions, we need to have at least 10 metric tons landed, and preferably 20 or 30. So we're going to have to scale up.
The improvement of safe landing techniques on Mars is, then, a priority. The NASA's project Journey to Mars will investigate the entry, descent, and landing techniques needed to reach the Martian surface, which will guarantee the success of the first manned mission, scheduled for the 2030s. NASA has also already started to study closely what the best location for our first home on Mars would be. These should be locations of high scientific value that would also provide resources to allow human explorers to live on Mars. Local natural resources such as water and oxygen are crucial for humans to explore Mars. Liquid water might be obtained from 3 sources: ground ice, which would be buried or beneath the surface, the atmosphere, or hydrated minerals. Oxygen, by comparison, can be generated from the carbon dioxide that makes up most of Mars's atmosphere.
There's a lot of disagreement about where the Mars base should be. The poles have an advantage because there's water ice there. But the problem with the pole is it's dark for half a Martian year, which is, say, almost a full Earth year. So that leaves you either with the equator regions or the mid-latitudes. They both have something to argue. The equator is the warmest, varies the least with season. But if you go to mid-latitudes, you can get places that always have at least some sunlight all year long, but which have some water ice too. Not big fields of it like the pole, but nevertheless deposits of water ice that are readily accessible.
My favorite site, we call it Noctis Landing, and it's in the western end of Valles Marineris, which is this giant canyon that cuts the surface of Mars. I love this location because it's at the bottom of the canyons, but at the same time it's in an area that's very wide and very open, so that you can see the Earth easily in the sky and maintain communication.
Other possible places considered for a first location on Mars are paradoxically outside the planet. They are the small moons Phobos and Deimos.
The Martian moons are the sweet spot when it comes to a potential settlement site.
We should use Phobos and Deimos as targets. We should send the first early crews just to make sure we can travel to Mars and come back safely, not to get too complicated. That will be already a fantastic adventure.
Both of them are much smaller than our moon. Phobos' mean diameter is 14 miles, and Deimos is just 7 miles, while our moon diameter is around 2,100 miles. The fact that they are much smaller means their gravity wells are almost non-existent. So landing and takeoff would be much easier than on the Martian surface.
The Martian moons are locked like our moon. They always keep the same face facing Mars. So if you wanted a place to explore Mars robotically, the best place to do that from is from the Mars-facing side of Deimos. Deimos is 20 times closer to Mars than our moon is to the Earth. So the round-trip light time to control things telerobotically is just a little more than 100 milliseconds.
These two little moons, so very close to the planet, might be used as a pit stop for the exploration and future colonization of Mars, and even for the colonization of the asteroids of the main asteroid belt, in orbit between Mars and Jupiter.
I think that they are very exciting places as a first step for humans to explore Mars. The very first missions to Mars, I think, should not try to land on Mars.
Once the location for our first settlement on Mars has been selected, the next step would be to decide which type of habitat to build so that the future inhabitants will have a safe place to live. The astronauts who walk on Mars for the first time may stay there for several months. As the Martian surface has extreme temperatures and the atmosphere is unable to protect them properly against radiation, they will need to have effective shielding against the hostile environment of Mars. NASA, with its program Journey to Mars, has started to explore different construction solutions. One of the most innovative concepts for sustainable habitation on the Red Planet is called Mars Ice Dome, which was designed for NASA by the company's Space Exploration Architecture and Clouds Architecture Office. This ice dome would be built using the most advanced 3D printing techniques. The Mars Ice Dome is a large inflatable structure surrounded by a shell of water ice. Water ice is an effective shielding material for galactic cosmic rays, and many areas of Mars have it in abundance just below the surface. So water ice is a great solution for building habitats on Mars. The Mars Ice Dome structure is lightweight, so it could be easily transported and deployed with robotics, then filled with water before the crew arrives. Another interesting aspect of the Mars Ice Dome is that the translucency of the ice washes the habitat with daylight, connecting the inhabitants to natural diurnal cycles and also lets them enjoy the views. Other construction solutions that involve burying the habitats before the crews arrive would require heavy robotic equipment that would need to be transported from Earth, which would make costs rise significantly. The Mars Ice Dome instead balances the need to provide protection from radiation without the drawbacks of an underground habitat. However, to make it possible for human beings to live in a hostile world like the Martian environment, we are going to need more than just a safe habitat. The colonization of Mars will also require a wide variety of equipment to provide services directly to humans and production equipment used to produce food, water, breathable oxygen, and energy. The first step will be to have life support technologies to recycle air, water, and waste in a closed recycling system and to utilize in situ resources. NASA is already providing advanced life support research and development of innovative technologies.
There are two ways to make the life support for a Martian habitat. You can either do biological or physical-chemical. The physical-chemical system is, frankly, simpler to implement and more reliable, and it's probably what we'll do first. What that does is it takes the water, the used water, and it purifies it and recycles it so you can recycle your water. That's the most important thing.
Nevertheless, for medium and long-duration missions, the life support system should be bioregenerative, a system that incorporates biological components in the synthesis, purification, and regeneration of basic life support commodities. It must be designed in such a way that the components are recycled or regenerated and don't need to be resupplied.
Which is using plants, and that's how the Earth does it. The way the Earth's life support system is that we breathe out water and carbon dioxide, and plants turn that into food and oxygen. And ultimately, that's what you're going to want. On a Martian settlement, we're going to want to set up greenhouses, and we will take the carbon dioxide that we breathe out and some of the water that we produce, and we will use it to grow plants. And they'll turn it back into oxygen and into food for the colonists to eat.
Those greenhouses will need a reliable source of energy that keep the functioning constantly. In fact, a source of energy for the general supply of the colony will be another key factor.
The energy source for growing plants on Mars is going to be Martian sunlight. The solar flux on Mars at the equator is about the same as that on Norway on Earth. If you go to Norway, there are forests, plants grow there, and it's enough. It's enough light to grow plants. Now, of course, the human colony needs more energy than that, just as we need more energy than just outdoor lighting in the daytime, which we use to grow our crops here. And you have basically two choices at the first, which is solar energy or nuclear energy.
The issue with the solar energy on Mars is that it is not totally reliable. A sandstorm could reduce solar energy for months, which could be fatal for the colony. For a permanent settlement there, we probably need to develop the Mars geothermal potential. But for a first base, the energy supply would be taken care of with just a small nuclear reactor. For any kind of colony that we are able to settle on Mars, we will need to study the different options of communication with Earth, made difficult because of the huge distance between the planets. NASA and ESA included communications relay equipment in several of the Mars orbiters, so Mars already has communication satellites. While these will eventually wear out, additional orbiters with communication relay capability are likely to be launched before any colonization expeditions are mounted. The one-way communication delay due to the speed of light depends on how far Mars is from the Earth. This delay makes real-time communication, such as telephone conversations or internet relay chat between Earth and Mars, highly impractical due to the long time lags involved.
To Mars, it can be as short as around 4 minutes, or as long as 20 minutes. Once in a while, if Mars goes behind the sun, you can't talk to Mars at all.
This blackout could be solved by using a future network of communication satellites, which would be a realistic solution for a full colonization program. There is no doubt that becoming an interplanetary species will require unprecedented technological and scientific effort. We know that to send a manned mission to a planet as distant as Mars will mean facing countless risks. Before the first human walks on Mars, a group of robotic exploration rovers such as Spirit, Opportunity, and Curiosity could be the outposts that pave the way and could help locate resources, such as groundwater or ice, that would be fundamental for the growth of the colony. The next step would be the progressive arrival of several robotic cargo missions to transport the equipment, habitats, and supplies. They should operate long before any manned mission. It's possible that this first settlement will be a scientific station to be able to do detailed in situ research into the Martian environment.
What I think we should be doing altogether, humanity, is to build an international research station at the surface of Mars, a bit like the International Space Station, but on the ground on Mars.
At present, several nations and organizations are developing long-term plans to send manned missions to Mars. NASA kicked off the Mars mission program with the launching and testing of the Orion Multi-Purpose Crew vehicle in 2014. The Orion is the first manned spacecraft intended to go beyond the low Earth orbit into deep space since the Apollo program. It has two modules, the Launch and Splashdown Crew Delivery Vehicle, and the Deep Space Habitat Module, where the crew will live during the 16-month-long journey from Earth to Mars and back.
It's a good design. Now, it was designed to be bigger than Apollo, so the crew could be a little larger. It's designed to have a multi-purpose destination.
The first manned Mars mission is currently scheduled for the 2030s. On this pioneer mission, the astronauts will be able to orbit Mars for the first time ever and then return to Earth. Therefore, on this first mission, no walk on Martian soil is planned. In addition to NASA, other space agencies have different plans for the future exploration of Mars. ESA, the European Space Agency, through the Aurora program, has a long-term goal for the robotic and human exploration of Mars, with the hope of finding traces of life. It has already sent robotic probes like ExoMars in 2016 and plans to send the next probe in 2020. India, Japan, China, and Russia also have different robotic missions to explore Mars to be launched in the coming years. China and Russia plan to send humans to Mars in the 2040 to 2060 timeframe, but they are still long-term plans that could vary in the near future. Therefore, the only national space agency that has the clear goal of sending humans to the Red Planet is NASA, through its ambitious plan Journey to Mars for the 2030s. In 2015, NASA announced the launching of this enthralling plan, a program for human exploration and colonization of Mars. Journey to Mars that will culminate in a permanent settlement there. It has 3 different phases: Earth-reliant, Proving Ground, and Earth-independent. The first phase, the Earth-reliant exploration, started a few years ago and should last till 2020s. It's focused on research aboard the International Space Station to study the effects of the lack of gravity on the human body during long-duration space missions. The second phase, called Proving Ground, will test the capabilities needed by future Martian pioneers to live on Mars through several missions operating near the Moon. This phase will last till 2030. In the first of these missions, the Orion spacecraft will travel without astronauts thousands of miles beyond the Moon for 3 weeks. The next step will be a similar mission, but with astronauts inside the Orion. This crew will reach a milestone never achieved in the history of mankind. They will travel further from Earth than any humans have ever traveled before.
The Orion is bigger. That puts some challenges into it, but it'll be able to carry a little larger crew, and it has this multi-destination mission design for it. But again, to land anywhere still is going to require another component.
Also in the 2020s, they'll send astronauts on a year-long mission to test and verify survival in deep space as the final step before our arrival on Mars. Finally, the third stage, Earth Independent, has as its ultimate goal to send humans into low Mars orbit in the early 2030s. To reach this goal, they will need to test the techniques of entry, descent, and landing on the Martian surface, and analyze how to use the in-situ resources. Science missions are now very advanced, as there are plans for a new exploration rover for 2020 and a round-trip robotic demonstration mission that will bring samples of Martian soil to Earth in the late 2020s. In addition to different space agencies, interest in sending manned missions to the Red Planet, there are also several non-governmental organizations and private companies that have shown the clear intention of making the colonization of Mars a reality. One of the most proactive organizations is the Mars Society, which is dedicated to human exploration and settlement of Mars and has supported Mars analog research stations in Canada and the United States. Its president, Robert Zubrin, is a confirmed enthusiast of Mars colonization, as he is sure that nowadays technology is advanced enough to achieve it.
I think we could see Mars colonization in our time. We could see it much sooner than most people think. From a technical point of view, we're much closer today to being able to send humans to Mars than they were to being able to send men to the moon in the 1960s, and we were there 8 years after Kennedy's speech. Okay, if we had a president who made a similar bold and brave commitment as Kennedy and stuck with it, we could be on Mars by the end of his or her second term.
One of the most advanced private projects which is considering a self-sustaining human colony on Mars is the SpaceX project. The Space Exploration Technologies Corporation, the so-called SpaceX, is an American aerospace company founded in 2002 by Elon Musk, Tesla Motors CEO, and former PayPal entrepreneur, with the long-term goal of developing technologies that will allow a human settlement on the Red Planet to become a reality. Their ultimate aim would be to create a self-sustaining community, not just an outpost, that could grow into a city. To achieve it, Elon Musk states that an essential condition is to radically reduce the costs of the trip. As with the present costs, it would be totally impossible. According to Musk, the key factors to achieving lower costs would be the full reusability of the rockets, refueling in orbit, and propellant production on Mars.
SpaceX started by proving that they could develop space hardware at 1/10 the cost and 1/3 the time of the mainstream aerospace contractors.
SpaceX's plan is to create a Mars colony with a sustained population of 1 million people, which would mean 10,000 trips there with 100 people per trip in a time frame of about 40 to 100 years. The spaceship is designed with a crew cabin on top and a cargo compartment underneath, with capacity for 450 metric tons of cargo per trip. The duration of the trip would be about 80 days at the beginning, with the goal of reducing trip time to 30 days in the future. If all the plans are achieved, we would be witness to the arrival of the first crewed flight to Mars in about 10 years' time. Until that incredible milestone is reached, the goal is to send cargo from the very first trips to Mars from now on.
Musk might be able to do it. He's going to have to be lucky, okay? He's very brave, he's very determined, but this is a game where you have to do everything right and roll 7-11 or doubles.
Thanks to unstoppable technological advances, the settlement of a Mars colony is no longer the realm of science fiction, but a feasible reality. In the coming decades, we might be landing, working, and living on Mars. This could be just the beginning of the interplanetary expansion of the human being in the solar system. Maybe in a not-so-distant future, our home will be in a very distant place, in one of those remote space colonies.